A car chase. One of 5 that night in Manchester, but the only one covered on infrared camera from the air.
No, it's abandoned. We've got it abandoned in a cul-de-sac. We'll try and give you a location soon. We've got 2 out of the vehicle on foot patrol, 1 in back garden.
The car was stolen. The thieves escaped, but left behind enough evidence to jail them. Silent, but damning. Material witnesses.
The car was removed to a police pound. Every inch of it was examined. The reason? A fax from Interpol. A car ringing operation had been uncovered. Cars were being stolen to order and shipped to Europe. 2 of these cars could be traced to Manchester. Each detail was carefully logged. Everything done in meticulous detail. To prevent cross-contamination and to facilitate the investigation which will follow. Seats painstakingly worked over with sticky tape to pick up hairs, fibres, skin or dandruff, any of which could identify the criminals. Debris picked up from the seats and floor. All of it isolated, protected from cross-contamination. All of it catalogued. Each area of the car then vacuumed, the evidence collected separately and separately logged. Real science in action.
At 8 o'clock, Detective Inspector Maddox was assigned to the case. His first job was to trace the owner of the car. Within an hour, he had the full details. A black Saab 900S. Personalised registration number FV33. First registered only 4 days previously. For Mr. Frank Verity. He lived in a large detached house in South Manchester with his wife and daughters. The daughters owned a pet dog, Joey. Mr. Verity was a good friend of the Chief Constable. The following day, Detective Inspector Maddox went to the forensic laboratories in South Manchester. He had an appointment to meet Dr. Sarah Copeland, the forensics officer assigned to the case. They'd worked together before.
Jim!
Sarah.
It's good to see you.
You've got something for me.
The car case?
That's right.
Now this could take a little time. 1 fragment of a crisp packet. Available in every supermarket in Britain. 1 bag of crumbs. Somebody ate a ham sandwich in the car. No idea who.
I'll ask the owner.
You've traced him?
Traced him? He's a friend of the Chief Constable's. He's never been off the phone.
Good. That'll help with these. Now, is the owner a white Caucasian with brown hair? A white Caucasian, probably female with permed hair. Or even African.
What?
Human hairs, Jim. All found in your car.
Sarah, the car's only 4 days old, and according to you, half of Manchester's been in it.
I'm sorry, Jim. That's your problem. I'm just telling you what's there.
He can't be.
And dog hair.
They've got a dog.
And a cat. And a guinea pig. And a rabbit. Now, I could do a DNA test and tell you the breed, but it doesn't seem worth it with this lot. I'll wait until you've got some more serious samples to compare.
Fine. Anything else?
Oh, we haven't started yet.
Go on.
Fibres, Jim. We found a few.
How many?
10.
10? In a car, 4 days old?
Sorry. 4, I think we can eliminate. They were found in places you could only get at when the cars were being built.
What about the other 6?
You ready for another lecture? Now, there are 2 natural fibres and 4 synthetics.
How do you know?
Simple. Now, this is a bit of science even you will understand. Don't worry, I'm not going to destroy your evidence. Wool. Cotton. Polyester. And nylon. So, spot the differences?
Well, the first 2 burned and left ash. The other one melted, and the last one smelled strongly.
Very good. So, natural fibres burn and synthetics melt. Now, wool smells of burnt hair. Okay. Cotton burns. Polyester melts, but there's also a flame. And nylon also melts, but it also smells. But I've gone a stage further. Now, these are electron micrographs of each of the fibres, wool and cotton, nylon and polyester. You will see that the natural fibres, wool and cotton, are rough and irregular, whereas the synthetics, nylon and polyester, are smooth and regular.
Why is this one triangular in cross-section?
I don't know, and I don't really know anything about these 2, except that this one is odd, and this one is, well, big.
And it's blue.
And it's blue. But we have to go to the experts to find out about that. I'll send those off to the BTTG. That's the British Textile Technology Group. If you go along there tomorrow, they'll tell you all you need to know.
3?
The triangle, the big blue one, and the odd one.
So the case became centred on 3 materials: a triangular fibre, a large blue thread, and a fragment of some unusual fabric.
At 2:30 the following afternoon, D.I. Maddox went to the British Textile Technology Group in Didsbury. Here they have records of most fibres manufactured in the world. His contact was Peter Carter, one of the researchers at the Institute.
Detective Inspector Maddox.
Mr. Carter.
It's Dr. Carter, actually.
Oh, sorry.
If you'd like to come this way, I've got everything ready for you. Your colleague, Dr. Copeland, was quite correct when she identified the materials. The 2 of them quite interesting.
The triangular one and the thick one?
The thick one is nylon, as Dr. Copeland said. And it is a fabric, but it's what we call a monofilament, and it's quite unusual to be found in fabrics. The triangular one is not unusual at all. You do know how these things are made?
Well,
We wouldn't mind seeing a short film we made some time ago.
no.
It may help. You see, it's often useful just to go over the basics. Here we are.
Where do plastics and fibres come from? Sunlight. Plants absorb it and convert it into living materials, the process photosynthesis. Coal is plants that died 250 million years ago. And oil is the remains of creatures that lived in the sea almost as long ago. Pump the oil out of the ground and you have the raw materials from which plastics and fibres can be made. Refine it and crack it and you can break it down into molecules called monomers, the building blocks of the modern plastics industry. Process it further and monomers can be joined together to form longer chains, polymers. And in vast processing plants, polymers can be created and assembled to produce a multitude of useful materials. By large-scale synthesis of the made-to-measure polymer structures, we can produce extraordinary versatile materials. Materials like fibres and plastics. In plastics, the polymer chains are random, tangled up like a bowl of spaghetti, giving a soft, easily worked, pliable material, plastic. But extrude it and this can happen. Polymer chains arranged in lines, most of them parallel to the axis of the extrusion. This gives the material its strength, the strength of nylon, polyester and other fibres. And without these synthetic materials, could the modern world exist? Plastics and fibres, both are polymers which can be made suitable for every occasion.
Feels like being at school again.
Well, it was made for schools. I hope you didn't mind.
Not at all.
So, as you can see, fibres can be extruded into any form. Even triangular forms aren't unusual.
Are they used for anything special?
Well, it gives the fabric a sheen. Now, this is the really interesting material. Now, I took this earlier. If you ignore the fabric, that's just polyester cotton. It's what's attached to it that's interesting. If you look, you can see there's tiny glass beads. They're embedded in a polyethylene coating. Now, I burned some of this. You can feel the glass. It's like grit.
Is it like the stuff that they make our reflective jackets out of?
Well, yes, but it's the wrong colour.
The wrong colour?
Well, reflective jackets worn by the police and the fire service are normally yellow or orange. Your sample was grey. It's probably made for a private company.
Is there any way of tracing it? The company, I mean.
Try the manufacturers.
You know them?
Well, yes, there's only one company that makes that sort of stuff in Britain. I've written it down for you, and the phone number. They're not very far away.
Oh, well, thank you. It's been a great help.
Haven't you forgotten something? Your second sample. Come next door. I'll go through it with you.
The second sample was to prove crucial, but how to identify it? That was to be demonstrated by the simplest of research tools, a Bunsen burner and a thermometer bedded in a metal block.
Well, the next thing we can do is to record the temperature at which your sample melts using this apparatus here. We simply place your sample on top of this heated block and wait for it to melt. There we go, and as you can see, your sample melted at 240 degrees Celsius.
What's that tell you?
Well, we know nylon melts between a range of 210 and 260 degrees Celsius. Therefore, your sample's nylon.
Well, thanks very much, Dr. Carter. It's been a great help.
It's okay.
The manufacturer of the grey reflective material was FHM Reflectives, and they were also helpful. A list of customers for DI Maddox to work through. It was a long and tedious job, but after 2 days there was a glimmer of light. Where better to run a car ringing operation? Who was more likely to bring so much evidence into a new car than a car valeting company? D.I. Maddox was a cautious man. He double-checked the location. His instincts suggested this was the right place. But instinct isn't evidence.
Now this is the really interesting material.
Is it like the stuff that they make our reflective jackets out of?
Well, yes, but it's the wrong colour. Your sample was grey. I mean, it must have been made for a private company.
He watched, observed, and tried to remember what the scientists had told him. But first, he needed to check the evidence for himself. He was sure the reflective material was the same. But what about the blue nylon?
And I really don't know anything about this one, except that it's, well, big, and it's blue.
And as you can see, your sample melted at 240 degrees Celsius.
What's that tell you?
Well, we know nylon melts between a range of 210 and 260 degrees Celsius. Therefore, your sample's nylon.
The pieces of the jigsaw fell into place.
2 days later, the owners of the car wash were arrested. They were charged with running a car ringing operation. The youths employed by them were charged with auto theft. Cleaning out so many cars meant that they were moving hairs and fibres from one car to another, which is why Mr. Verity's car had so much evidence in it. All were found guilty and sent to prison, trapped by witnesses who never said a word.